Well, hello students, welcome back to Mathematics class with me, Mr. Alfie. In this video, we're going to learn about dependent events. Let's check this video out. So, to understand what is exactly dependent event is, let's jump to the example. Two balls are drawn at random from a bag containing 3 red balls and 5 green balls. The balls are drawn one after the other without replacement. Let A be the event that the first ball drawn is red, and B be the event that the second ball drawn is green. So at first, there are 8 balls in the bag. After drawing the first ball, there will be 7 balls left in the bag, because we will not returning back. If event A happened, that means the first ball drawn is red, the remaining balls are 2 red ones and 5 green ones, as you can see here. So the probability of event B is actually 5/7 because event B is the green balls drawn. So 5 green balls out of 7 balls inside the bag. So still, if there are 8 balls, if event A does not happen, the first ball drawn is not red, it means the first is green. The remaining balls are 3 red ones and 4 green ones. So as you can see here, the probability of event B, event that getting green balls, is 4/7 because there are 4 green balls remained here out of 7 balls inside the bag. That means the probability of event B depends on whether event A will occur or not. Thus, A and B are dependent events. How do we calculate the probability of both event A and B occurring if they are dependent? It means we're going to find the probability of the first ball drawn is red and the second ball drawn is green. As usual, we make the 3 diagrams. So this is the 3 diagrams of this case without replacement. At the first ball drawn, there are 8 balls, 3 red and 5 green. So the probability at the first ball drawn is red is actually 3/8. And the probability the first ball drawn is green is 5/8 because there are 5 green out of 8. If at the first drawn will get red, that means there are 2 red ones remains and 5 green ones remains. It means the probability we will get another red at the second round is 2/7, or we get green at the second round is 5/7 because there are 5 green per 7, 2 red per 7. Let's bring back the red ones. So if we get the first ball drawn green, so the probability of we will get red at the second round is 3/7 and another green at the second drawn is 4/7 because there are 4 green ball remains and 3 red balls remain. So 3/7 and 4/7. Now, this is the favorable outcomes for the first red and the second green. So the probability of red at the first and green at the second is 3/8 times 5/7 equal to 15/56. It comes from this one multiple with this one. Next example. 2 letters are selected at random from the word mathematics. Find the probability that only one letter is vowel if the selecting is with replacement, and B. Find the probability that only one letter is vowel if the selecting is without replacement. Mathematics, as you can see, there are 4 vowels and 7 consonants. For A is actually independent event because for independent event the keyword is with replacement. So for B, that is dependent events because the keyword for dependent events is without replacement. So The probability that only one letter is vowel if the selecting is with replacement. As you know, in the word mathematics there are 4 vowels and 7 consonants. So the probability that the first letter selected is vowel is 4 per 11, and the probability of the first letter selected is consonant is 7 per 11. Whether you got vowel or consonant, you will return it back, you replace it back. So the probability of you got vowel at the second, if you got vowel at the first, it will be the same, 4 per 11, and the consonant is also 7 per 11. And so does with the first drawn consonant, still 4 per 11 for vowel and 7 for 11 for consonant, because you return the selected letters back. So the favorable outcome for one letter is vowel consonant and consonant vowel. So the probability of one vowel is 4 per 11 times 7 per 11. It's from here, vowel times consonant, and consonant vowel 7 per 11 times 4 per 11 is actually 28 per 121 plus 28 per 121 equal to 56 per 121. How about B? Find the probability that only one letter is vowel if the selecting is without replacement. Remember, without replacement. We know that from the word mathematics there are 4 vowels and 7 consonants. If we got vowel at the first letter selected, it means there are 3 vowels remained. So 3 per 10. Remember, we take one letter, so it becomes 10. For the consonant, it's still 7, but per 10. If we got the consonant at the first letter selected, so the probability of vowel at the second selecting is 4 per 10. Still, there are 4 because we got consonant at the first, so 4 per 10. And for a consonant is 6 per 10 because we got consonant here, we not return it back, we not replace it back, so the remaining consonant is 6 per 10. So these two are the favorable outcomes for one vowel consonant plus consonant vowel. So for the vowel consonant is 4 per 11 times 7 per 11. For consonant vowel is 7 per 11 multiple with 4 per 10. So it is equal to 28 per 110 plus 28 per 110. It is equal to 56 per 110.